In this video, we're going to learn how to identify and name acids. So acids, we'll see them in more detail later on, but they are substances that when you put them in water, they increase the amount of hydronium ion that's there. And hydronium ion, we sometimes just call it hydrogen ion, but hydronium is actually H3O+, or you could just abbreviate it as H+. That should work just fine. So what that means is when you put the acid in water, it will separate into H+, and then this other ion here. This H+ is what makes something acidic. So generally, acids contain an H+. They have an H in the front. So HI, hydroiodic acid, HI is an acid. H2SO4, because of this H, is an acid. That's sulfuric acid. H2O wouldn't be an acid because that's HOH, and when you have the H and the OH together in equal amounts, that's neutral, we say. So don't think that water is an acid, okay? But everything else with an H, for the most part, we'll consider an acid. So how do you identify acids? By name? Well, by name it's easy because the word or the name of the acid actually has the word acid in it. Hydroiodic acid, sulfuric acid. Okay, so no tricks there. If something is an acid, it will have the name acid in it or the word acid in it. It's a bit more difficult when you're dealing with a formula. Usually when you have the formula for an acid, it's going to start with an H and then it's going to need an aqueous here. Okay, so you need an H to start with and then an aqueous as well, because an acid can only act as an acid if it's dissolved in water. That's the only time it can release the H pluses to actually behave like an acid. So there's actually two types of acids we're going to learn about. There's acids called binary acids and oxyacids. Binary acids are acids that have an H, they start with an H, and then there's a nonmetal. So for example, HCl is a binary acid. There's an H and the nonmetal. HI, aqueous, is binary, H and nonmetal. H2S is binary, an H and nonmetal. Binary, again, bi meaning two, only two elements there. One is an H, the other is a nonmetal. Oxyacids are those that start with an H, and then they have a polyatomic ion that contains one or more O's. So HClO3, H and then polyatomic ion, chlorate, ClO3, or H2CO3, aqueous. H and then polyatomic ion, carbonate. So if you want to name and write formulas for acids, you need to first identify if you have a binary acid or oxyacid, because the naming rules and formula writing rules are a little bit different depending on what type of acid you're dealing with. We're going to start off with the naming and formula writing rules for binary acids like HCl. So if you want to name a binary acid, what you do is you put the prefix hydro in the front. You put the element name root. So for example, chlorine, the root is chlor. You replace the ending ine by ic. So hydrochloric, and then you put the word acid. Hydrochloric acid. If you want to write the formula from a name, you need to recognize it's binary, and you'd know it's binary because the prefix hydro is in the front. You would write X first. You would write H first, and then the subscript would be the charge of whatever nonmetal is there. So for example, if I say hydrochloric acid, H first, chlorine, its charge is -1, so just put a 1 here, and then put a Cl there, and then you have to put AQ. Since you don't need the right one, you can just put HCl, AQ. So let's do a few practice problems together, examples together. Here we want to name HF. I know it's a binary acid because there's an H, there's an F, and then there's AQ. So there's two elements only, and we have our AQ, which signifies we have an acid. So since it's binary, I have to use the prefix hydro. So hydro. Fluorine becomes fluoric. and then acid. Formula for hydrochloric acid. So I know this is binary because we have hydro in the front. Oxyacids actually wouldn't have hydro. We'll learn that later. So we'll put H. Charge of chlorine is 1, so no need to put a number there. And then Cl, and then AQ. You need to put the AQ. If you don't put the AQ, then you don't really have the acid. For example, if I just wrote HCl, and then let's say I put gas. This is actually hydrogen monochloride or hydrogen chloride gas. It's not the acid. You really only act as an acid when you have the AQ there, because in water you can release the H+. All right, so you can pause the video and try the following examples yourself, and then unpause to see if you're on the right track. HBrAQ, to name that. Okay, I know it's binary, so I have to use a prefix hydro. Bromine becomes bromic. And then I have to put the word acid. Hydrobromic acid. Great. Let's try the next one. H2SAQ. So binary, because there's 2 elements only. Starts with an H, has an AQ, so it's an acid. Hydro. And then sulfur. It's a bit of a different one here. Sulfur becomes sulfuric. Hydrosulfuric acid. Hydrosulfuric acid. All right, hydroiodic acid. We know this is binary because of the hydro in the front. H, the element is iodine because it's iodic here. That has a charge of -1, so I don't really have to put a subscript for H. I just put the I here and put AQ. So that's hydroiodic acid. So that's how we name and write formulas for binary acids. Now let's take a look at how we would do this for oxyacids, like HClO3, which is chloric acid. You'll notice right away in this name there's no hydro. And that's because hydrogen, yes, it's important, but there's also oxygen who wants some attention as well. So we're not going to make it all about hydrogen, even though technically it is. So when you're naming oxyacids, do not start with hydro. Start off by writing the name of the polyatomic ion that's present. So here, for example, it's chlorate. Now, here's the next step. If your polyatomic ion ends in ate, change that ending to ic. If the polyatomic ion ends in ite, change the ending to ous, us. So ClO3 from your polyatomic ion chart ends in ate. So this becomes chloric acid. And that's how you would write the name for an oxyacid. Just write the name of the polyatomic ion out, change the ate to ic or ite to us, and then put acid. No hydro. That simple. To write a formula, you would simply write H first, put the charge of your polyatomic ion, and then write the polyatomic ion, and then put AQ. So if I said chloric acid, well, you need to know, okay, chloric came from chlorate. Okay, great. I would put an H first. Chlorate is ClO3 -1, so I put a 1 subscript. Don't really have to write it. And then ClO3, and then AQ, just like that. Okay, so let's try some practice problems out here. Name HNO3. So first of all, we know this is not binary, so I wouldn't be starting with hydro. I need to go find what NO3 is called. NO3, you have this table all the time. NO3 is nitrate. NO3, that's nitrate. So I'm going to write this out here, nitrate. Since I end in ate, that's going to be replaced to ic. So that's going to be nitric acid. Next, we're going to try HNO2. Not a binary acid, oxyacid. I need to go find what NO2 is. NO2, notice, is nitrite. Not nitride, nitrite. So as you know, if you have ITE, you have changed that to OUS. So this is actually nitrous acid. All right, the formula for chlorous acid. So first of all, notice it's not binary because we have the OUS and we don't, well, and also we don't have hydro in the front. So if we have the OUS, this must have been ite, chlorite. So I'm going to put the H first and go find the charge of chlorite. Chlorite is ClO2 with a -1 charge. So ClO2 with a -1 charge. That means I have to put a subscript of 1 for H, so you don't have to write anything. And just put ClO2 and then AQ. And there is your chlorous acid. Okay, next, you can try this one on your own. Carbonic acid. The ic, so there's no hydro, so I know it's binary. It's not binary. The ic, that means it must have been a polyatomic ion ending in 8. So this is actually carbonate. So carbonate, if you go look at your table, is CO3 -2 or 2 minus. So I'm putting H, subscript of 2, and then CO3, and then aqueous. I'll put 2 more for you to try. So I want you to try naming H3PO4 AQ. I want you to make a formula for phosphorus acid. And then I want you to name H2SO4 AQ. So pause the video, try these yourself, and then unpause to check your work. So H3PO4, PO4 is phosphate. So it's not phosphic, it becomes phosphoric. So phosphoric acid. Phosphorus acid, the OUS indicates that that must have been phosphite, PO3 3 minus. So that means we have H3 has that's the charge of phosphite, and then PO3. And don't forget your AQ. Okay, H2SO4, not binary, so we don't need hydro, we know that. SO4 is sulfate. So we change the ending to IC, but remember it's sulfur, which is one of those weird endings, so it's actually sulfuric acid. Similar to a name we saw earlier. The name we saw earlier was hydrosulfuric acid because this was binary. So we put hydro in the front. But over here, because it's not binary, we don't put hydro in the front and it's sulfuric acid. Let's do one more. Name this one here, H2SO3AQ. So notice the differences. You got to pay attention to detail here because there is a difference. It's not the same acid. Here we have a 3, here we have a 4. So you need to recognize that this here, SO3, is actually sulfite. Sulfite. So that sulfite wouldn't be sulfuric, it'll be sulfurous. Sulfurous acid. So in this video, we briefly saw what acids are. We saw how to identify acids by name and formula. And we saw 2 types of acids, binary and oxyacids. We learned the naming rules for binary acids and also formula writing rules for binary acids, and naming and formula rules for oxyacids as well. In the next video, we're going to take a look at how to name and identify and write formulas for bases.